sentire qua, giusto?
Allora, l'importante è che quello non me lo stacchi subito dopo.
È
acceso?
Non lo so.
No, aspetta. Good evening, everybody. Hi. Hello, everybody. Am I in the frame? Sono nella... Mi riprende quello?
La borsa.
Questo? Sì, yes. Ok. Sandro Saitta. Sandro Saitta. Shut up. So, good evening, everybody. This is our second time with Potenziale Espresso Tech. I'm really glad that so many people joined. We actually reached about 100 people tonight. Not all of you are here, but anyway, it's still good to see that so many people enjoy it. Tonight, it's going to be in English. Last time it was in Italian. Today we have Vittorio and then Professor Villari, and both agreed to do their talks in English. So for once, the subtitles are going to be in Italian. Okay? So, as you saw on the invitation, we're going to have two hosts that are going to talk to us about some very interesting stuff. I'd say let's start immediately with Vittorio.
Thank you so much. And thank you so much for organizing this. I've been bothering you for a long time because I wanted to start, or at least to see a tech community start in Messina. So thank you so much for that. Hi, everybody. As you can see, the setup is a bit, let's say, rudimentary. So I'm going to try to not give you, to look at you while I talk, but sometimes I'm going to have to turn around. Hope you don't mind that. Today I'm going to talk to you. Okay.
Sorry, just one thing. Nobody touch that cable. The HDMI is really wobbly. If it moves even just a micron, it won't work. So please, nobody touch it.
As I was saying, the setup is pretty rudimentary. So anyway, today we're gonna talk a little bit about game development. I'm gonna show you how to make a game from scratch. We're gonna see a lot of code. So hopefully you like code. If you don't like code, hopefully you like it after this presentation. And if you don't like it, then you can, insult me afterwards. We're gonna have some networking. A little bit about myself. I am right now a senior C++ software engineer at Felix. It's a robotics company that is in Munich, Germany. I work remotely. And we are working on that little robot over there that goes underneath pallets and moves them inside warehouses. It's used by DHL, Amazon, and other places. I used to work at Bloomberg for 10 years. I worked in London and in Lugano, and there I was doing as well C++, software engineering, and technical training. And I also have my own business. I'm an independent training and consultant, and that is my website if you're interested. I also do a lot of stuff on the side. I have a YouTube channel and a blog where I talk about C++ and game development. I co-authored a book with some of my friends and colleagues. I spoke at over 30 international conferences in C++, and I'm a representative of the Italian national body in the C++ standardizations committee, so I also help evolve the language. I also like open source, and I am obviously a game developer. You can find some of my projects, and later if you're interested, we can chat about that. And I like playing volleyball, so if you play volleyball and you wanna hang out and start some games, please find me afterwards. And these are some of my games. This is called Bubble Bite. It's my last game, and it's an idle clicker game like Cookie Clicker, if you played that, inspired by my cat, and that is my cat. And then I made some arcade games, Open Hexagon, and I dabbled with virtual reality. I did some VR modding for popular games like Quake and Half-Life 2. And again, I can show you later if you're interested. This talk is not about me. It's gonna be about how to write a game from scratch. So first of all, you might have no interest in games, but I want to get a little bit of a show of hands. How many of you people play games? Not enough people. I'm disappointed. How many of you make games? Has anybody tried to ever build a game from scratch? Cool. There's a few people. So in general, I feel like games are a fantastic art medium. and they are an artistic endeavor across multiple domains. If you want to make a successful game, it has to be compelling in terms of gameplay. It has to have a nice art style, nice graphics. The story can also be very important. The audio, the music. So to make a successful product that is remembered and people appreciate, if you are an individual, you have to basically touch all the different topics on your own, or you have to start a team, communicate, collaborate. So I think it's one of the art forms that covers very different wide, a very different range of skill sets. If you want to build a game, you can also get involved with the community. There's a very rich and diverse game development community that will help you out. And if your game becomes popular, you can start your own community and introduce more people to the world of game development. And also, even if you don't really care about building your own game, you mentioned that you play games. Some of you also might work on simulations in the future, on real-time software, and having an understanding of how these things work under the hood can really give you a nice appreciation for all the work that goes behind a game and all the work that goes behind real-time simulations. And mostly it's fun. It's something that I enjoy. I'm one of those weird people that after work goes home and works, because I like working on my own projects, I like working on games, and I find it very rewarding to be able to write some lines of code and actually see an action appear on the screen or something that changes visually. It's a very rewarding and process that has very direct feedback when you're writing some code. So I really like that. Okay, so that is the introduction. I will apologize to my Italian friends. This is going to be the end of the live captions because we're using PowerPoint, but I'm not going to present in PowerPoint anymore. So sorry about that. Hopefully you will understand what I'm going to say. We are going to look at some code. I'm going to build, or rather going to show you the steps required to build a game from scratch using my favorite language, C++, and a very nice library which is called Raylib. So generally speaking, to build a game, you need some sort of library, some sort of additional dependency that gives you access to the graphics, to music, sounds, keyboard, and so on. And Raylib is probably the easiest and most accessible and simplest library. It is very simple, but even commercial games have been shipped with Raylib, so it's something that you can also use to build a real product if you're interested. And this is what we're going to build. Very simple version of Arkanoid or Brick Breaker, however you want to call it. We're just going to have a little player that moves at the bottom of the screen, a ball, and some bricks, and we have to destroy them. Now, I only have 30 minutes, so I'm going to try to implement the most important things, give you an idea how these things work under the hood. And then if you're interested, of course, I can share my code with you, and then you can improve over it, iterate over it, and add more features and interesting game dynamics. Cool. So I'm going to jump into my editor here, and I'm going to show you step by step how we can build a game. So I don't know how many of you have written C++ before. Has anybody worked with C or C++? Of course. But nowadays, it's all Python, right? And I think we are losing a bit of that direct contact with the hardware, that low-level programming, which I think is also really helpful to understand how machines work. So hopefully, this is going to also spark some interest in you into these lower-level languages. So what we have here is very simple. We are including the library that I mentioned, Raylib, which is providing graphics, windowing, keyboard access, and so on. We have some constants for our screen, which is a very old resolution, but this is the projector we have, so we're gonna deal with that. And then here we're just initializing a window with some name and the variables we mentioned before, and we are setting a target frames per second, so how fast we want our game to run. In this case, 60 frames per second, which is a good standard for these sort of things. There is some noise. Okay. Manu. Yes, there is some noise in the background. Okay. Anyway, so if we run this program, you will see that the window immediately disappears, and we get to the first interesting part of game development. Pretty much any sort of real-time application or something that requires input from the user operates in a loop. We have a continuous main loop that runs all the time until the end of the application, until the end of the game, that repeats the same steps over and over again. And this is what keeps alive the application and how we can actually process the data that we're working with. Usually the first step is getting input from the keyboard, the mouse, whatever. Then we update the simulation. This means that we execute game logic, we move things on the screen, and then we draw what the game logic actually represents. So if we have some positions, some sizes, we can transform them into shapes, rectangles, circles, whatever. So to make our game actually work, we do need a loop. This is what it can look like. We can have a while loop that iterates continuously until we want to close the window, which basically means until somebody presses the X or S on the keyboard. And inside the while loop, we're going to use some functions from Raylib to start our drawing process. We want to begin drawing. This is basically going to initialize the surface of the window where we can draw stuff on. We're going to clear the background to black, and then we're going to end the drawing. And we repeat this in a loop forever. And if you see this in action, it's going to be very, very impressive. We have a black window. That's all it is. And again, if you never worked on a real-time application, this might seem surprising to you, but literally everything has to be part of this loop. The entire game is going to be executed inside the while loop. So what can we do with this? Well, inside the while loop, between the begin drawing and end drawing functions, that's where we can put the logic of the game that dictates what gets drawn on the screen. So in this case, we have a nice little function from Raylib called drawCircleD, which takes a position that's going to be a 2D vector, so x and y. In this case, my x and y are both going to be 128. Then it's going to be the radius of the circle, so this has to be a little bit more here. And then the color of the circle, which is going to be green. So in this case, we're going to draw a circle at this position with this radius and this color. So pretty self-explanatory. And again, if I run this part of the application, you will see a little circle on the screen there. And again, might seem weird if you've never done this before, but literally every single frame, we are clearing the entire window, drawing the circle, and doing that over and over again. That's how games work. You basically recreate the entire frame every single time that you go through the loop. Okay, we want this thing to move, right? So how do we do that? We need to store the position and the velocity of the ball into some variables that we can mutate over time. And then inside the loop, we can actually, for example, move the ball with a certain direction or a certain speed. And if we draw the ball every single time, then we're going to be able to see the movement of the ball in action. So in this case, what I've done here, I have two vectors on lines 13 and 14. The first one is going to be the position of the ball. It's a variable, so that means that we can change it over time. And then the second vector is going to be the velocity, which in this case is going to be a constant. It's just going to be 3 units per second, per frame, sorry. So in the while loop, before drawing, that's usually where you do your updates, where you mutate the state, where you advance the simulation. And what we're doing here was just basically adding the velocity of the ball to the position, first for the x component and then for the y component. So we're continuously adding onto the ball velocity and position. And I think I have a diagram for this, which is self-explanatory. But basically, every update step, so every frame, we are simulating the motion of the ball just by increasing the position by the velocity. It should be pretty self-explanatory. So if we actually run this code, you will see some motion. So the ball moves, but eventually disappears. It disappears because we haven't written any logic that prevents the ball from going outside of the boundaries of the screen. So how do we fix that? So we need to check whether the ball has reached the boundaries of the screen. So an easy way of doing this is thinking about the ball as a rectangle and using our knowledge about the position and the size of the ball to figure out what are the edges. So what is the right edge of the ball, the left edge of the ball, and so on. So in this particular image over here, we can figure out that the right edge of the ball is going to be the position of the ball at the x coordinate plus half the width, which is the radius. So if we check that the right edge of the ball has gone beyond the boundary of the window, then we know that we are exiting the boundaries and we have to react to that. And you can apply the same exact logic for every side of the window. So to show you how that looks in code, let me just go forward a little bit. This is what we're going to do. We are going to calculate the edges, so the left of the ball, right, top, and bottom. And as you can see here, these are very simple calculations. We're just getting the center of the ball, which is the position, and then either adding or subtracting the radius to figure out where we actually are on the edges. And then, for example, if we want to check if the ball has exited the window on the left side, we can simply compare the left edge of the ball with the 0 coordinate, because that's how the window coordinates are dictated. The 0 coordinate is the left edge. And if we have gone beyond the left edge, we can simply flip the sign of the velocity by multiplying it by a -1, so that the ball will start moving in the opposite direction on the x coordinate. And we can repeat this logic for every edge. So if we're going outside on the right side of the window, we can again flip the velocity and then adjust the position of the ball to prevent it from going outside. And we can do the same for the top and the bottom. And I think I also add a diagram on the window somewhere. So let me find that. Sorry about that. There we go. So this is what the window looks like. And this is why we are comparing against 0 and the width and the height, because in Raylib and many other libraries, the top left corner of the window is going to be 0, 0, and the bottom right is going to be width and height. So this is why we're using this sort of comparisons here. So if we run this example over here, which should be number 5, you will see that eventually the ball will react to the edges of the window and will bounce, or at least will give you the illusion of bouncing on the window. And just to make it clear, for example, if we look at the code and the screen at the same time, you can imagine that as soon as the ball reaches this coordinate 0 over here, we're going to flip the velocity so it starts going to the right, and then we adjust the position so that it stays within the boundaries. That is the idea behind this code. Does that make sense to everybody? We have time, so if you have questions, I'm happy to take questions. Good? Cool. Awesome. So what else? We want to be able to interact with the ball, so we want to introduce a player. If you played Arkanoid, that thing, the rectangle that you move with the keyboard is called a paddle. So we're going to create a little structure for it and introduce some constants. It's pretty simple. The paddle is just going to have a position and a velocity, which basically tells you where it is on the screen and how it should move. And also, we're going to have a speed and a size, which are going to be constants, and you can decide whatever you want for these values, but I found this one to be decent. Then we create an instance of a paddle, so we have an object named paddle of the same type at a certain position with 0 velocity, because we want to control the velocity with the keyboard. So by default, it's going to be stationary. And this position here is just going to be basically somewhere around the bottom of the screen in a way that looks nice, and it's centered on the x-axis. So don't think about this too much. It's just some calculations. The important part is that we also want to draw it. And in this case, we want to draw it as a rectangle. So Raylib gives us another function called draw rectangle v that, given a position, a size, and a color, will display it on the screen. So same with the circle, but just for the rectangle this time. So if we run this code over here, which should be number 6, sorry, maybe number 7. It's a bit hard to see on this screen. There we go. You have the rectangle there. We cannot do anything with it right now. Like if I press my keys, it doesn't move. And if the ball happens to intersect with it, nothing happens. We also have to write that code. We have to react to this sort of conditions as well. So you probably get the idea now. We have to figure out, is the ball intersecting with the paddle? And if it is, we have to change the velocity and position of the ball to react to that intersection and make it bounce off the paddle. So how do we do that? There is this little diagram that I made that shows you how you can detect collisions between rectangles. They are called AABB. It stands for Axis Aligned Bounding Box, which means there are rectangles aligned to the coordinate system that you're using. They have no rotation. They are rectangles without rotation. And basically, what you want to figure out is, looking at the edges of these rectangles, is there any overlap, either on the vertical side or the horizontal side? And if there is overlap in both cases, then you have an intersection. It means that these rectangles are one inside the other. And this is how you can detect collisions in general between two rectangles. Most games you play use this as an initial phase for collision detection because it's very fast. And then once they figure out that the collision is with the bounding boxes of your objects, they might have a more precise one afterwards to detect the actual collision. But this is the backbone of all collisions in any game, and this is run millions per time per second on any game that you play on your computers. So this diagram makes it look a little bit too daunting, but it's actually quite simple. what we're gonna do is we're gonna go by an exclusion process. So what I'm gonna do here is basically, I'm gonna take the left side of the ball, so the left edge of the ball, and I'm gonna take the right edge of the puddle. And then I'm simply gonna compare them. If the left side of the ball is greater than the right side of the puddle, so it's to the right, if the left edge of the ball is to the right of the puddle, then it means we cannot have a collision. It means that we are completely on the right side of the puddle. So there is no intersection. So we exit early from this function and we have not found a collision. But if the left side of the ball is to the right of the puddle, there still could be a collision. We have to check the other coordinates. So what about the left side? So if the right side of the ball is less than the left side of the puddle, then in that case, we know that the ball is completely to the left side of the puddle, and again, there is no collision. So we are excluding all those possibilities. And in the end, after checking all four directions, if there is an intersection in all four of these directions, then we get over here, and we can basically deduce that there is an intersection between the ball and the puddle. So it's an exclusion process. You can write this in a lot of different ways. It doesn't really matter, but the principle is the same. We are just checking what we've seen in the diagram. So if there is, I need to zoom out. I cannot do that from the screen. Okay. So we are basically checking if the sides of these shapes are intersecting with each other on all four directions. So if that is the case, you should be able to see that now the ball will react to the collisions with the puddle. Again, it's pretty primitive looking, but this is the backbone of every sort of game that requires collisions and requires interaction with the user. Other thing that I've added here is, of course, the interaction. I can move the paddle with the left and right keys on my keyboard, and that is also very, very simple because Raylib makes it very convenient. All I've done here is I simply check if key left is down, and if it is, I'm going to move the paddle to the left, by setting its velocity to a negative value. Otherwise, if my key right is down, I'm going to move it to the right by moving it with a positive velocity. Otherwise, I'm going to set it to 0 to keep it still in the same position. And again, the velocity is something that we set, and then we use it to mutate the position of the paddle to move it forward by that more complicated, and I don't have much time. So what I'm going to do is I'm going to give you the general idea, and then if you want, we can dive deeper into it later on in the networking session. But the idea is pretty much the same. We have the data for the ball that was just position and velocity, the data for the paddle that was also position and velocity, but for the brick, because they don't move, they're stationary, all we need is a position and also something that tells us how big the bricks should be, and that is the constant called brick size. In this case, a brick is going to be 50x wide and 24y tall. And then we have to have multiple bricks. So one of the things that C++ gives you is a data structure called vector. If you use Python, this is basically a list. If you use Java, this is an array list. If you use C#, this is also a list. But C++ decided to be different, and it calls it a vector for some reason. And this list of bricks is what we can use to basically store multiple bricks and dynamically decide how many we have and what we're going to do with them. This function here looks weird, but all it does is just creates a grid of bricks, just calculates nice positions to make them look nice onto a grid. And once we calculate those positions, we're just going to put them into the vector. And this is how we do it. We push the brick back into the vector, and we add it to the list. And again, if you work with Python and Java and other languages, pretty much all of them have an equivalent that puts something into a list in C++, which is called the pushback for some reason. And then the last thing I just want to show you is that, sorry about that. Eventually, we also have to use the same logic that we used for the ball and the paddle to check collision between the balls and the bricks. So we have the same function here, I just wrote in a different way, but I'm calculating the edges and the overlaps and checking whether the ball intersects the brick. And this function over here is something that we're going to call into our loop for every single brick. So you can imagine that every single iteration of the game loop, so every single frame, we're going to calculate the intersection between the ball and every single brick. So this seems something that could be expensive if you have a lot of bricks, a lot of balls. But again, computers are extremely fast, and this sort of operation is done in nanoseconds, and you don't have to worry about it. And games, modern games, do this millions, if not billions of times per second on a much larger scale. But the principle is exactly the same. You want to check all the objects against what they should be checked against and compute every single frame whether there is an interaction that needs to happen. And once we have this in place, we can just add it to our main loop over here. I did change some code around to make it a bit more organized, but just to show you what it will look like if I manage to run it. We have some bricks, and we are able to destroy them. That's all there is to it. Of course, this is not a real game yet. You cannot lose. You don't have lives. You don't have, status text or anything like that. But again, I'm just showing you the idea behind it. The way you should think about it is every single frame, I want to do a lot of things to simulate motion, check collisions, and eventually react to those actions in my game. And if you get creative, if you spend some time polishing it, making it a little bit nicer, maybe use some AI to help you out. That's what Professor Villa is going to talk to us about. You can get to a nicer sort of version of it, where you can add some effects like this trail, these particles, change the color, give a little bit of oomph when you hit the bricks, and it shakes the screen a little bit. And you might have the next indie game that could make millions of dollars. I don't know if you ever, if you follow the indie gaming news and stuff like that, but very simple games made with 2D libraries like this one, like Balatro or Terraria or games like that, games that anybody could have made, they made a lot of people very rich. So if that is your motivation, you can make the next it. But I think what I want to show you is the fun of it, the visual feedback, and how simple, how easy it is to work on these games. It's very accessible and also teaches you a lot of skills that are widely applicable in the real world. So that is my presentation. That's what I want to show you today. And just to finish up, I'm just going to go back here. This is a QR code containing my links, my information. You can find also my GitHub page where this code will be uploaded. So if you're interested in seeing the code, you can actually find it on GitHub, or I can send it to you directly if you're interested afterwards. We have plenty of time for questions, so I'm happy to take more general questions, or if you want to dive deeper into any part of the code base, I'm also happy to do that. Marco. Come here. Yes.
Wow, very professional. Thank you for
You have to use both.
Great. Okay. Thank you for the presentation. So you store both the velocity of the brick and the ball, right? And to me, it makes sense that you store the velocity of the ball because you need to upload the position. You need to remember it from the previous frame. But why do you store the velocity of the brick as well? Because it could stay the same. Yeah.
Okay. So it's a good question. I guess the alternative would be that instead of storing the velocity, you directly apply the change onto the position, right? That would work in this particular case, but as soon as you introduce, for example, collisions between the paddle and the edges of the screen, you have to react to those. So by adding the position, you will go outside the screen. By using the velocity, it's much nicer to have a system where you basically say, the velocity just changes the position unless there is a collision, and then you basically roll back to the previous position. So in this case, you're right, it could be even simpler. But in general, separating velocity and position makes sense. And if you think about expanding the game, adding more entities, what you would usually do is you would have a base entity class that has position, velocity, all the stuff, and you can implement everything on top of that just to make it a bit neater. But it's a very good question.
Thanks.
Any other questions?
I have a question
Of course.
for the audience.
Yes.
It's a much more comment. I want to hear from you. So some crazy guys, like in the games, they say, I don't like how they are performing, and today are one of the top company in the world, NVIDIA.
Mm-hmm.
Why they started from game? What is the issue behind the chain that you are presenting to us?
Mm-hmm.
Thank you.
So it's a very good question. So what Professor Villa is talking about is NVIDIA. NVIDIA nowadays is probably the richest company, right? It's the richest company in the world. And they have transitioned from working on products for gaming, GPUs, graphics cards that you could use to accelerate games, onto AI. And I find it really fascinating. In general, what happened is very organic, really natural. The story is basically that games require a lot of calculation. I showed you before these diagrams with all the collisions and the drawing and so on. And these calculations are expensive for a normal CPU to perform. So what happened is that companies created dedicated chips, dedicated hardware that works specifically for graphics in games. And these hardware are very, very parallelizable. So basically, you can run a program that runs for every pixel on the screen in parallel. So it's very fast, but also very limited in that sense. However, over time, they realized that the same hardware works really well for AI problems. The sort of calculations that you perform on LLMs, like ChatGPT or whatever, they are calculations that are very easily parallelizable and that they work on GPUs. So NVIDIA took the opportunity to say, okay, we are making GPUs already. We are very successful. We have the resources. How about we actually transition onto the market for AI? And now they are the primary source of GPUs made specifically for both training and inference in AI, I think to OpenAI and probably some other companies. I know that Google has their own TPUs, which is different, but NVIDIA has had a great opportunity. I think in general, there is a lesson to be learned here that the sort of skills and the sort of performance required in games, which has to be very, very high, especially as more complicated the games become, really requires a lot of deep knowledge of hardware and deep skill into programming. So another reason why I really recommend people to learn game development or at least try it is that it's a very nice gateway to deepening your own skills and understanding how high performance computing works. Any more questions? Awesome, thank you.
Just allow us a couple of minutes to switch from one computer to the other and set up the slides for Professor Villery. Professor Villery, if you want in the meantime to introduce yourself, I mean, no need for introductions, really, but
So what I want to say you today, we're here from starting from scratch for understanding some slides I presented in the summit in Vienna, but I'm adding piece by piece to know where we are today, because it's important, following what Vittorio said, to follow the way. There are some crazy minds in the world that are making a lot of business. This is the domain. This is the domain of business. This is the domain of new stuff. I introduced myself if the system works. Can you verify? Nobody knows about you. And at some point, but you have to stop to say, guys, we can make progress. Guys, we can do something really important, even from a small city like Messina. As some colleague, you said, lovely city. I agree. It's beautiful, have a great weather. I have to say, you 1 week ago it was a -2 in Vienna, so cold for me. I prefer to have 20 and to stay on the beach because I need to be inspired. Okay, and what is great for my Sicily, Sicily allowed me to be inspired. Unfortunately, by the food, but you can see it, and it's something that we really know. But not only it, even the relation with the people and the staff. This is what I think all the students appreciated. This is what we like to do. We need a step further. We need to make a business, to stay on the place. I'm working on that. Some of you know that we're pushing for a high hub with the municipality because my idea is to bring all of you and to work in the morning and then to the night because we need both. Okay, I have some ideas in mind. Okay, I forgot to put my clock. Otherwise, Professor Villa talk too much. Okay, and I don't want to bother you too much. Okay, let me open it. This is what I do when I go abroad for my keynote, right? Okay, I have to recover 5 minutes. LLM, and Vittorio already introduced it, is a strange word, large language model. Today we are here for better understanding what we are talking about. Okay, this is a strange situation, as you can see here. I don't know if the laser works, by the way. And understanding where we're moving, because this is what I mentioned, the positive aspects that we need to figure out. What's happened in the last 3 years, it was an outcome, ChatGPT 2022 was in November. And what's happened from there to here? And then what is the future? This is the future, what I slightly introduced it to my colleague in Vienna. I talk about agentic AI. What is this new stuff all around? Okay? Uh, what happened 3 years ago, guys? Why all the people are talking about ChatGPT, Gemini, or OpenAI in general, all the algorithm? What's going on behind the shade? The first situation, and why to make a jump? Because AI is there for hundreds of years. For sure, the last 50 years, something's happened. Okay, but why today we talk about it? Well, something that Vittorio introduced a little bit was a matter of brilliant people looking at the parallel system and try to push in maximize the capacity of hardware. This is what's happening. Okay, and but we have to be careful. Okay, I forgot to ask you, but in case I will catch you later, what is the implication with job apocalypse and what's going on? We have to be careful, guys. Okay, because if the game can be done by ChatGPT, we're in trouble, Victoria. No, so we know human in the loop is important, but we need to understand how we position humans in this future. Okay. So I like cloud. Messina was one of the first participating one of the main projects in Europe, named the Reservoir. I was one of the architect of that time. They were struggling understanding what is this cloud. We're talking about 2006, 7, 8. It was really the beginning of everything. Why I'm mentioning new clouds? Because clouds make the difference. Cloud started the opportunity to have social media. Cloud started the opportunity to have Uber, Airbnb, all of Amazon, very famous, Google, all the big players started from clouds. Keep in mind, it's there. And cloud was the difference for modern AI. Okay, I will show you why. And yes, this is machine learning. You say, what is machine learning? Try to mimic in our brain. We understood that in our brain has some the HDMI. That's, it's funny, man said, nobody has to touch. He touched it. Okay, don't worry. I can talk without slides. And I was showing to you this structure, essentially is a structure for our brain. We understood there was some stimulus as an input, something we learn by medicine people from biological stuff, and then we put in hardware. Okay, say okay, we can balance this crazy stuff. I'm putting these guys to know. I'm trying to recognize the number and write the number two. Okay, and what the brain should do, we don't know. We're talking about 80 billion neurons. Okay? What they do, there was some stimulus from now high, and say, okay, what I'm seeing look like a number, look like a number two. And our brain says, oh, is the output two is number two. Essentially, it's trying to balance all the elements. And what it does, look for the shape of the number, looking for the border of the number, for the color of the number. Of course, in this case, it's black and white, but try to put in place everything, try to scale up, scale down, say, this is a statistical speaking number two. Is it clear how machine learning works? Simple. And then we are able, during the time, to go in Mars, thank AI, to recognize signals, to recognize DNA, because instead to recognize number two, I can recognize your DNA to say, we have the disease, or you should have the disease in the next 10 years. So you can see Massimo, you hit a lot. This is my DNA. What to do? Okay, it's fine. And even these numbers, as we said before, number two, number three, number five. This is the scale of AI. For a long time, we said machine has to think like humans. This is what we said. I like to split the word by two. And I like to mention one of the biggest companies in this perspective is Google. They are crazy people with deep mind and so others. And what's happened? There was a, let me say, year zero in 2015, 16, 17. That's the age, the period. Okay. Before they're struggling to see your computer with AI, number two, number four. At some point, somebody says, no, one computer is not enough. I have a cloud. I'm Google. I can use 1 million computers. Why one? You can have a distributed intelligence. Oh, great point. And we started from 2017 to figure out what Vittorio showed to you. Algorithm. Why is it possible that one pixel is managed from one computer, another pixel from another computer, another pixel from another computer in parallel? Because if I have 3 computers, I will be fast, for sure. And Victoria can benefit of it, okay? Intelligence today, okay? It's a marriage. I like to put the symbols on the table to allow you to remind what's going on. And the marriage was done by brilliant algorithms, but one computer, not too much, where we leveraged the great idea of cloud. What is cloud? Distributed computing, parallel computing. 1,000, 100,000, million of virtual machines all around the world that can execute for you a task. In the same computer that is able to watch the Super Bowl, and you have 10 customers, in 20 minutes you have 1 million customers, and you scale up with the 10,000 virtual machines to allow you to see the movie. And then when the movie finish or to see the match, then the system go down. Scalability up and down, okay? Only cloud can do it, guys. Never happened in the past. This is what's happening. But this is not only the story. At some point, some of you remember, no, Vincenzo, also the others, the analogical stuff, music and things. At some point, we moved everything digital. And everything is digital today. I remember the year 2000. There's a brilliant company like Kodak. I bought my camera from Kodak. Do you know Kodak anymore? You don't know Kodak anymore. They disappeared. Because they say, no, I have analogic, I'm fine, I'm okay. I'm the leader in the world. They disappeared. Why? Because you have to take actions. It is important because today we have a revolution nowadays. We have to understand what's happening. You cannot say, I use analogic because I'm the leader. No, you disappear. And today is another moment. Nobody can say, I don't use AI because you disappear. Okay, guys? Is it clear the message I'm trying to deliver? And then there's a kind of a shape like umbrella. Every day we produce a double of data of the day before. Okay, a lot of data. Today we mention it like big data. We started with the million of data, then billion, and today we go for terabytes, for petabytes, are strange numbers. Facebook and Instagram, they produce petabyte every month. We're going to exabyte. Peta is 10 power 15, 1 5. Exa is 10 power 18. And we go for zettabyte. So a lot of data, a lot of bytes that we can use for some reason. Okay. Keep in mind, cloud for computation, scale up, scale down, and data. Okay. And Google said, come on, I have the same issue 2003, 2004. I remember very well my colleagues in California, they started this strange search engine, white page, symbol field, and you can search something. They're happy. They make agreement to Oracle, or at some point they don't scale. They make a search, just pay the 10 seconds to index the full internet. They were slow. We cannot say slow. Oracle said, you need a big machine, big machine, big machine. And I said, no, I cannot have a big machine. I can have 10 machines, 100 machines, 100,000 machines. Okay? And they move with another brilliant concept, map reduce. I can give you a parallel. You need to pipe this building. It's easy to pipe this building fast with 1 pointer or with 10. With 10 or with 100. What you need to do is to assign tasks. You go the front part of the building, you go the back part, you go the side part, you split the work. There is a mapper, somebody give you the work, you do the work. At the end of the day, 5 o'clock, let's go to jump here to have a beer. What you finish it, okay? This is the great paradigm of Google. Map, reduce, marginalize. You split the job, you do the job, you resume and say, okay, what is missing? See you tomorrow. Is it clear, the story, guys? Makes sense. As everything Vittorio said to us. Strange things, game, but makes sense. Simple line, simple ball, simple computation. That's it. Okay? And then we started with upscale. Great idea of Google. Let's have a map reduce. And worldwide, all the company started looking machines. Vittorio said a strange word, high performance computing. Computers are fast, many of them. And we look, hyperscale is Google. I heard this company, Google. Is Amazon? I heard this company, Amazon. Is it Microsoft? I heard this company, Amazon. Oh, guys, are the same company of AI players worldwide. What is missing there? What is missing there? What told you? We don't see NVIDIA. I was in Hamburg last year, talking Amazon, talking with Microsoft, with the Huawei. All of them says the big signs. Don't worry, we have upper scale computing for you, Massimo, and we have NVIDIA. So NVIDIA is there. Anybody has NVIDIA. It's clear. It's not written there, but it's everywhere. Okay, because they're making business. Take you to what? Gaming, starting point, blockchain, mining, and today AI, because they were brilliant. Is it clear, the story up to now, guys? Very well. Okay, this is the important papers for AI people, 2017. Okay, from Google, DeepMind, London is the place where you were. Okay? I'm supposed to go there. I was there in for Flower meeting on AI last March. I will be there next March. What they said, no, we have a lot of computation. We have map reduce. We have to invent something. It's brilliant. It should go in parallel. They said, we need to invent something new. We need to transform our concept of AI. Okay, guys? And they said, we need attention. Because up to now, up to that moment, do you want to recognize AI? You look at your vocabulary, you see Massimo Villari. No. Massimo Villari is here presenting to you. It's a sentence. It's a context. Put your attention in the context. Put your attention in one sentence, in 2 sentences, in 3 sentences, not in Massimo Villari to count them. Doesn't work. You have to put context. Google was the first example to say that a sentence has a meaning. To sentence another meaning. Your paragraph of your book is a meaning. You have all the attention in a session, paragraph, chapter, book. It makes sense. You need to focalize on the context. Is it clear the story? Very well. And then started this great idea to look different, to think different. And they invented transformers. Do you know, which of you knows what is the acronym of GPT? Generative Pre-trained Transformers. Full of data and full of brilliant idea of the crazy guys of Google that lost the business when OpenAI started in the picture, but today is back thanks to Gemini. Nobody's paying me by Google, but they're brilliant, to say honest. Okay. You look, Google Translate, and then we go for generative. Do you know what is a generative? You have a strange monster. You put noise data as input, but you train it with a lot of phase of us, and phase, the system generates n+1 new phase not existing anymore. Is it clear how powerful is the tool? This is why it's a generative AI, because it's able to look forward, to go behind what's happening today. Okay, guys? Is it clear up to now the story? Very well. A ChatGPT was a brilliant combination of looking the paper, went to the guys, NVIDIA, and with the server, put money, Elon Musk, Hartman, and the others, say, we need to make an experiment. What experiment did they did? They took all the internet and they push it as a crazy system with transformers. They say, go by yourself, train by yourself. And the monster appeared in November. They make a prompt, and the system answered it. And they said, it's a bomb. It's crazy. It's a weapon, because it was very powerful. Nobody thought was so powerful, guys. Okay, this is why I said, what's happening? It's like a monster. Okay, nobody understood that the system trained it now one way. Let me say, not to think, at least to talk. Okay, often we're now talking about natural language processing. Okay, what does it mean? The language is clear, and why that? Because we have books, we have newspaper in all the language, and the system was crazy. It took the way to understand the context. It put the right attention on books, on sentence, on papers, and all the stuff. Okay? Is it clear why it's brilliant? And what we did, guys, we trained it with some kind of automatic label system by the internet, because we said there was a cat, and then it was a caption of a cat. There was a book, title, there was abstract, and we wrote the title and abstract. So by the data, big data, and by the computation, big computation, and by NVIDIA computation in parallel, thanks to what the transformer does, okay, we are able to do what? Remember the brain I showed to you? The lines and stuff, they were able to adjust themselves. They were able to adjust the parameters. They are able to adjust the weight to recognize number 2, number 24, or to recognize Massimo is presenting AI. Is it clear? The same brain, but it's huge brain. It's not small one with the 4 neurons and 2 layers. No, we don't know how many layers they are. We don't know how many parameters we are. What do we know? There are billion parameters. Okay? This is the game of today, guys. But what I want to remark you guys, system lost, Massimo Villari presenting, hello everybody. No, the system goes by numbers. These numbers are defined as tokens. Okay? The system is not able to think. The system is able to approximate numbers in the right position, in the right sentence, statistically speaking. Is it clear? There is no hello word. There is 1, 2, 5, 500 linked to the vocabulary. Okay, are numbers. Do you think numbers can be general AI? I don't think so, in my personal opinion. They are numbers. They are helping us. Okay? Again, this is the original system on the back with the network I showed to you about AI. This is what we have today. Pre-train it. Okay. And then we go for fine tuning with reinforcement learning. Do you know what is reinforcement learning? You ask something to ChatGPT, OpenAI, say, no, it's wrong. Okay, I adjust. When the system adjusts, it's a learning thing to you. This is defined fine tuning in reinforcement learning. Is it clear, the story? Okay. And look at the trend. Nothing happened here. LLM. And look here. It's a trend on Google that become massive. In few years, revolution. Okay, guys? And we need to identify the revolution because it's something totally new. And then we have the plethora of algorithms. All the algorithms in the past, a lot of algorithms today. Gemini 1.5, can be 3 today, 3 Pro. And what is happening? Why ChatGPT 4, then ChatGPT 5? Simple, guys. Tokens, context window, and parameters by the age. Nothing else. This brain is becoming bigger, 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 so big that some of them announced they need a power plant in any form to supply energy for this crazy system. Every time you use a prompt, seems that you consume. In Google, the past was a cup of coffee. Today, we don't know what is the money. A lot of money for a simple prompt. Why? Because you make a prompt, you go in Mountain View in Google, or you go in OpenAI, or where you want, a lot of computation, a lot of NVIDIA cards, power supply, energy, and also thermal issue with water, energy and water, and then you come back with the answer. It's an unsustainable way. Okay, guys? This is what is AI. It's AI is hungry of energy. Okay? Is it clear, guys? Okay, and then what we're doing, we go for ChatGPT, 175 billion parameters. What they are parameters? Tokens, weights, connections, like in our brain. And we're not happy because we are going for 1.8 tera parameters. Is a billion is a 10 power 9, tera is 10 power 12. Tomorrow can appear to Altman and say, we are 10 power, I don't know. A lot of parameters that are entering the picture, okay? And then we go for multimodal because we can recognize picture, we can create image, we can have the video, remember Veo video from Gemini and so on and so forth, because we are putting a lot of layers, a lot of parameters, a lot of real data where to come from for our model. What is this? Is the training. The model is able to train because by million of video, 10,000 video, 10,001 is able to generate it because he learned by the previous video, he learned by the previous audio. And then there was a big scandal. There was AI that call you the bank account and say, move money of Massimo Villari, I Massimo Villari move to another one, to Vittorio. It was a fake. We are assisting to the fake voice, to the fake face, fake video. And how? Because they trained it by my system. They trained it by voice. In this moment, somebody is recording AI. Every time there is a phone call worldwide, there is an AI system. It's recording my voice. Tomorrow, there's a bastard voice I'm recording there, will ask money instead of me. It's true, guys, because it's there in the system. They are recreating my system vocal. Okay? This is the bad things, negative of AI. Remember positive? Positive is the destruction. Positive is a great idea. Negative is taking my voice to do something that I know today. Okay? Okay, you see August, ChatGPT 5, then you have Claude, Gemini, and blah, blah. Every 2 months, there is something new in this domain. Okay, guys? This is what's happening. Okay? And then we're working a lot in Messina in distributed intelligence because we cannot be bigger. And Europe like a federation. So that means you cannot have a big cloud, big Google, big Amazon. So let's try to link each other to make it stronger, no? And we try to federate. Europe will go for federation, okay? And one of the main topics nowadays is federated learning. Federated learning, you know what is? When you open Google, a European Commission said you cannot use AI algorithm. Google use an algorithm in your keyboard, but don't disclose the data, disclose the model. The model is possible to put everywhere, data not. data privacy. Okay, federated learning is great for data privacy. This is where we are today, that we are not centralized anymore for data. Data stay in your smartphone, data stay in your laptop, and the model will exit your smartphone, your laptop, to have a shared model with all the people all around the world. Okay, this is how today we are looking for a positive AI for the future. Traditional ML and federated learning, you stay on the edge. The edge is your smartphone, your car, your television, because you push all the data on the cloud will be OpenAI, the cloud will be Gemini, and you can be in trouble. Okay, this is what Europe wants to push us to do. You see here all the models, and then you deliver the models of a central server, and tomorrow you can use the model for somebody else without disclosing data. Is it clear the concept of federated learning? Just to say where we're going and to see the future. And there was a big company I met it's from Cambridge in London. It's a platform named the Flower. In Messina, we're working a lot with the Flower and also LLM in federated learning. Why? Because we want to prevent the privacy of the system. The future, guys, agentic system. I was in Vienna last week for my keynote talking about agentic. I removed many slides, complex, but I can share it with you if you wish. They appreciate it a lot. Agentic. What does it mean, agentic AI? Okay. So agentic is looking for workflow. Agentic is something that behaves instead of me. It might be hard. Okay. I need to see the mail. I need to answer the mail. I need to save the mail. And if the mail is received, I have to open some tickets on the web. Many actions. So you can do one action with one prompt. You can make many actions with more prompts and more agents. Okay, this is what is agentic AI. It's a modern stuff. What we're working a lot worldwide. Some colleague from Stanford, some colleague from Sydney, some other colleague from London. I'm going to Nantes next week because we are looking how to use agentic AI in orbits. Okay, unfortunately, we are in the military era where all the people are looking how to progress in this domain, and this is where we are working on. Okay, mining, orchestration, and decision making. So the email is good and bad is not enough. You have to download the mail, to look the text, to react according to that mail. Is the mail for student? Is tomorrow the exams? Yes, tomorrow we have the exams. We meet tomorrow, okay? And but the idea to have multiple actions to collaborate each other. This is the new frontier on LLM named agentic AI. Okay, autonomy, adaptability, and goal orientation. That means today I have 100 of emails. I have to answer. My goal is to finish the day, you make the work, and stay on the beach. I like the approach of agentic guys. Okay, can stay here to take a beer, right? You see, as agentic works, they are all together collaborating is the kind of picture, and then we move forward. Agentic is something new. We started with the new LLM, and today we have new of agentic. In blue is agent AI, one prompt. In red is agentic. They are entering the picture, and worldwide is talking about that. Something, as I said, architecture. You can have one agent for email filtering, content recommendation. All of them are agents. Okay, just to say you what I mean. Look, this example. Agent is on the left part of the picture. It's too hot. You can open air conditioning. Do you know the system Nest, the thermometer of Nest? It's an AI agent, but it's not there. The picture. The picture is where there is some clouds this evening. My garage is open. It can rain and there can have some issue. The agentic AI perform all the action myself. This is what we are looking for, even Messina, for the future. Okay, and then we are putting in place pushing documents, a report. This is why I want to use a RAG that allow you to enrich the behavior of LLM. Okay, what is RAG? The capability to contextualize my thesis, because I want to work in my thesis, my report, or my weather condition. I put the document, and the system answer according to that document. Okay, this is a new item that we are using in LLM. Okay. Okay, let's move on to understand what is happening, guys. Let me say some negative stuff. I think I'm using 5 minutes more. Okay, I apologize, but Professor Villa talk too much, you know. Important business aspect. I like this picture. This picture is named Gartner curve. Okay, Gartner curve is like people, or woman and girl and men falling in love. No, they have a big expectation. Oh, great, great. Then you have the disillusionment, and then you can get married after some time. You know, or you finish all the position. If you see, let me go back. On top, we have AI agent and AI agent for data. Okay, this is what's happening today. According to Gartner, Gartner was a big company worldwide looking for a business approach of this AI idea. Look at the Gartner because without the business, we cannot have improvements of technology. If there are money, people push where money. Okay, it's important for us. Okay, let me move the next slide. And for AI, it seems that distributed intelligence, the intelligence at the edge, seems to be the future. Okay, LLM has to exit the centralized approach with a lot of energy, a lot of water, toward still very brilliant, very great, but at the edge with the usage of less resource. Okay, this is what is happening. And then today, every day, there is a big bubble AI exploding. What is this bubble AI? They're putting a lot of money. NVIDIA push money. OpenAI with Halfman push money. All of them push money. People are saying, oh, where's the money finish? We're talking about a trillion. Trillion is a 10 power 12. Because a billion is 10 power 9 dollars. A trillion is 10 power 12. A lot of money. You know, at some point, we cannot continue talking about money because money finish and then we explode. We hope not to be killed by the bubble, but we have to be careful because many money around the concept. At the end of the day, you need to see something concrete in the fog. Okay, this is what is happening. You see, 100 billion. There is Altman with the NVIDIA CEO. I say, okay, I need to spend on NVIDIA. So they put money each other because they need the NVIDIA card, but they need to also to make some progress in this investment. And this is what I really don't like, guys. The CEO are pushing all the employees to use AI tools. Some company also in Italy are happening this. Calabria knows what they do. They say, okay, use it. And what's happening? When the system train how you behave, they're fired. Bye-bye. It's a clear story. This is true negative approach. What is happening with today LLM? We need to be careful, okay? So I link what Vittorio said. Look at the gaming, to how the system works, because tomorrow we still need humans, but humans that think different, that have the basis, with the great basis in gaming, in programming, and make stuff, but look into the future. Because for sure, the gaming is presented, Vittorio is presented before, we done by LLM. We cannot stay there. We use the gaming for understanding the game, but we need to move forward. This is my message, positive message to all of you. Naturally, I am a positive message. You see, Google, I said many times Google, but the brilliant guys does something at the basic, making inputs from the model, 200 people fired in one shot. Is it clear, guys? Be careful, okay? This is what can happen. Another great thing, another great story, last month, Deloitte, big company worldwide, he went in Australia government, say, I can give you the report, what is issue your stuff, 5 seconds of ChatGPT. They recognize it, and the report costed $400,000 US. They would push back the money to say apologize because it was done by ChatGPT in few seconds. Crazy. Doesn't work in this way, guys. It's a negative approach. What is happening? Okay, read your document, read your thesis, read your report. Okay, because otherwise it doesn't work. It's quite easy. I like to say the Nobel Prize. Jeffrey said during last year event in London, there was a ceremony in front of the king. It was a great say, no, it's no artificial intelligence. It's artificial intuition. It's true. I fully agree with this concept. It's no intelligence. We cannot say we have a general AI. The system cannot really think. It's a reasoning, can do something, but we need to put our emotion in place. I don't see emotion in hardware. just to be clear, in computer and stuff. Long way to go. Something also I met. I tried to push Jan LeCun to come here. We should come next year. Okay, yeah. I sent an email. For the moment, it's quite busy. By the way, I said we don't care. We don't care about the LLM. It's a simple machine with numbers, and it's not. Look at this picture. Is important for you. The people that disappear, guys, just to inform my students, will be junior students. Don't stop in bachelor degree stuff. Okay, go towards master degree, senior student, or exactly even PhD, because this is where we have to go. Not to push you to study more, but the reality is what is simple to do will be done by LLM. That's it. The Stanford survey saying that 3 months ago, and they said what is simple to do. Alessandro said that. You go by the prompt. You can have some people make a newspaper. Am I right? This is what we said. It's true. It's becoming totally true. Be careful. This is the negative situation, but this is the positive message that I want to push you for. Just say one. The NVIDIA CEO said, "Don't worry, humans can do something." We hope that it will be really true that humans can do something different. As I said, for Jan LeCun was last week #2 on Meta. He's an AI scientist. I know him very well. I met him many times at a worldwide conference. All the time he said, Massimo, we need to push people to understand we don't care about LLM. It's a matter of, look what is written here. If you are interested in human level AI, don't work on LLM. Okay? It's a great tool. It's behave very well, but it's no general intelligence, artificial general intelligence. Thank you, guys. I hope you enjoy it.
So, any questions? Please come. In the meantime, there's a very good book that just recently came out by an Italian, by the way, not working in Italy, of course, Luciano Floridi, I don't remember how to pronounce his name, which is called The Fundamental Difference. And it talks just about this, how we have to stop calling it an artificial intelligence and rather call it an artificial agency, because that's what it is. It can act. Actually, it only acts, right? It doesn't think. It can tell you it's thinking, but
it's not.
That's not what's happening.
There are numbers. Yeah. If you think there in our brain there's a number like that, I don't believe so. Both, yeah.
Okay. Hello. So I just want to ask, like, what is the difference between the RAG and the MCP service that we have in place?
Yeah.
And it works kind of similar, but
no. So just to be clear, MCP is a matter of protocol that allow you to differentiate the model. I named about we can say many things. I named about the fact that we have agentic. Agentic are many agents. Okay, many agents can be OpenAI agent, can be Gemini agent. There are many. So the cloud infrastructure say no. We have to make clear. We need a protocol to interact the same way with all of them. With what? With the token, with the prompt, and to have an answer. You can ask the first, you can ask the second, you can ask the third. This is what the protocol MCP can allow you to have a general interface with interacting AI models. Is it clear? And when I talk about AI model, it's the inference model. You ask, you have an answer. One aspect. In terms of RAG, essentially we're trying to enrich the knowledge of LLM. So it's one of them. So it can be 3 or 4 by the protocol, but you can focus in one of them and you push documentation. And what is happening in reality? Okay, essentially the number we were seeing there, in the simple way how to look to token, the numbers are extrapolated by your document. So that means your answer will be filtered at the end of the story by the document that say maybe the context is the book is about weather report. The book is saying it's about the weather. It's not about something else, about how to buy the car. It's not buy the car. It's a look at the weather is beautiful or not. If I were to clean the car, Okay, it's not buy the car, it's cleaning the car. Because I'm pushing you the document about the weather of tomorrow, you look, okay, it's about cleaning the car, it's about buy the car. I don't know if you explain to you difference between MCP and RAG. Please, Vittorio. Yeah, ce l'ho in mano.
So you mentioned and you reported people mentioning that LLMs are probably not the way to AGI.
Yeah.
I don't know that. I honestly don't know. Like, because from scale, sometimes things emerge. Right? You can think of the brain of an animal, the brain of the human being. Is there a big difference? Is it just scale? So maybe as we scale, we will see more things emerging. So I don't know. But my question is, are there any new sort of like fundamental different models compared to LLM that are being researched that are showing promise? You've been to many conferences, so you're likely seen some.
So there is some model named Khan. What we're working today, I was in Abu Dhabi last December because my PhD student spent some time there with Professor Karai. This is the missing point, Victoria. We need to look at different models because we adapt some models in this parallel system. We have not finished it yet. Okay, this is why we said we are working a lot on chronology graph. Well, our PhD student, brilliant Rosario, I don't know if you know him. He received a feedback from Node.js database that said we never use the approach we are using. So in some way, we are trying to differentiate because the answer tomorrow is we need to differentiate, to look at the different models. Because what we have done now is to take the original models and to bring them in a scalability way. It doesn't work. I'm sure it doesn't work because we need to have a better solution in our problem. And what is important to remark, now our brain consumes 20 watts. 20 watts, and we have any answer interact with each other. For sure, is not the way to go in increasing the scale, increasing. We have a great success, a great situation, but we don't believe that. Let's make a parallel. If you look at the thermal engine 100 years ago, it was a crazy engine, then we make it better. This is the time to make LLM better. We were astonished to say, oh, what's going on? But we were there, and then we have to take different models. Can be Khan, can be KJ, like chronology graph. We don't know yet, but for sure we need to investigate new way. But starting what you said, look at the simple algorithms, look into the games, understanding how they behave, and to apply. Okay. Thank you.
So now, couple of things. Next week, we're going to have Potenziale Espresso entrepreneurship and freelancers. So you're welcome to come. It's going to be on Thursday, as usual. The week after that, we're going to have the international version, but it's going to be on Tuesday because we don't want to overlap with Eda's birthday. So now we're going to start the networking part. So we're going to lower the lights, and right now we're starting the yeah, exactly. We're going to lower the lights, turn the music on. Let's have something to drink, something to eat, and thank you, everybody. If you want to talk to Vittorio or Massimo, please do so. We have them for the night, so make use of this time. Thank you.